guys, we are Avengers Assemble.
Hi, my name is Natasha Vidya Bersata and I'm from PASCAL.
Hi, my name is Tuan Muhammad Islam Idronso. I'm from FSKIK.
Hey guys, my name is Shanti Jivadas and I'm from FSKIK.
Good day everyone, my name is Krishna Subramaniam. I'm taking Diploma in Science Computer. I'm from Faculty of Arts, Computer and Industry Creative. I hope you guys everyone enjoy this video. I'm going to talk about basic counting principles. Counting problems are a lot there, and one of them is how many different letters are there in passwords, or how many possible ways are there to pick 11 saucer players out of 20 player team. Probabilities are important in counting, which is like what is the probability of winning the lottery. To solve those problems, we have the sum rule. If a task can be done in n1 ways and a second task in n2 ways, and if these two tasks cannot be done at the same time, then there are n1 plus n2 ways to be either task. Example, the department will award a free computer to either a CS student or a CS professor. How many different choices are there if there are 530 students and 15 professors? Here there's the sum rule works. There are 530 plus 15. We need to plus them and then we get 545 choices. Another sum rule which is called generalized sum rule. If we have tasks to T1, T2 and so on that can be done in N1, N2 or so on ways respectively, and no two of these ways tasks can be done at the same time, then there are n plus n2 plus nm ways to do one of these tasks, which is like we need to plus the basic counting to get the sum rule.
Like this, like the red one, blue one, green one and the white one under the 4-cylinder engine. You also must do the same to the 6-cylinder engine like this. Okay, so if we count how many possible outcomes are there, we could just count like this: 1, 2, 3, 4, 5, 6, 7, 8 and 8. And 8. So the 8 possible outcome, and it makes sense, right? Because it has 8 bubbles here. And you also have the 2 possible engines. It means 2 times 4. And it's equal to 8. So the possible outcome is 8. We also can draw the diagram like this. We use the red, blue, green and white as the main bubbles, and we just add the 4 and the 6 bubble equally into one of them like this. But the probability is still 8. Okay, so that's how we use tree diagram to calculate the probabilities. Thank you.
Today I want to explain about my topic. My topic is PASCAL triangle. Okay, in mathematics, PASCAL triangle is a triangular array of binomial count. The rows of PASCAL triangle are conventionally enumerated with row n equals 0 at the top, the odd row. The entire in each row are number from the left beginning with k equals 0 and are usually stacked relative to the numbers in the adjacent rows. The triangle may be constructed in the following manner. In row 0, the topmost row, there is a unique non-zero entry, one each entry of each subsequence row is constructed by adding the number above and to the left with the number above and the right, treating blank entires as zero. For example, the initial number in the first or any others row is 1. The sum of 0 and 1 with the numbers 1 and 3 in the third row are added to product the number 4 in the fourth row. Okay, in PASCAL triangle, each number is the sum of the numbers to it upper left and upper right. Okay, one of the most interesting numbers pattern is PASCAL triangle, name of Blaise, a famous French mathematician and philosopher. Okay, to build the triangle, start with one. Start with the 1 and at the top, then continue place number below it in a triangular pattern like this. Okay, is the number directly above it at. Okay, here I have highlight 1 plus 1 equal 2. If you want to find the number in this okay, yeah, this if you want to know how this become a 3, you just 1 plus 2 so equal 3, yeah, and all this in the same way. Okay, now so next pattern with the triangle. Okay, this we call ones, and this counting numbers, and this one is triangular numbers. The first diagonals. Okay, the first diagonal is of course just start with 1, and the next diagonal has the counting numbers. Must be 1, 2, 3, 4, and next. The third diagonal I have a triangle number. The fourth diagonal not highlight. Highlight has the tetrahedral numbers. Okay, that's all. I hope you understand. Okay, enjoy. Goodbye.
Talking about the pigeonhole principle. Basically, in mathematics, the pigeonhole principle stated that if n pigeon are put into m pigeonhole, which is the formula is n is greater than m, which is pigeon greater than pigeonholes, then at least one pigeonholes must contain more than 1 pigeons. For example, there are 10 pigeons and 9 boxes. So how do I accommodate 10 pigeons into 9 boxes? So, for example, we have 10 pigeons and we have 9 pigeon box. We just put it in one of the box each. So we can cut down this, 2, 3, 4, 5, and you'll be remain with 1. So where did this little fella go? So there's no problem, there's no need to worry, because this guy can occupy in any one of the box, meaning in one box there will be 2 pigeons. So you can put it here, either here or here. Next is the generalized pigeonhole principle. For this principle is quite different from the last one, but it's almost the same. Okay, for this one is they gave you the number of holes and you have to find the number of pigeon. The definition of it is if n pigeonholes are occupied kn plus 1 or more pigeons, where k is a positive integer, then at least 1 pigeonhole is occupied by k plus 1 or more pigeons. For example, find the minimum of a lecturer in the office is to that the 4 of them are born in the same month. So just now the question is, Find the minimum of the lecturer in the office is true that the 4 of them are born in the same month. Okay, for this one, it's quite confusing, but it is, okay, we can do it. So now we have to highlight the main thing, which is the 4, the number of the lecturers, and the month. So, okay. So now just imagine 1 year have 12, we have 12 months altogether. So for this question, it means that in just 1 month, it probably will be January, September, June, and so on. So for example, in January, there's 4 lecturers that was born in that month. So let's just denote M as the letters that we need to find the answers of. So let's just put it as an M. So for the N, so for N again, we're going to use the formula Kn plus 1. So the N is the number of the month, are in the same month. Altogether the month there's 12. Okay, let's denote N as 12. Okay, so now we have to find this Kn plus 1. What is the answer to that? So our K plus 1. Okay, we just cut down N because we already got the answers for it. So N, we could close it. And now let's focus to K plus 1. So K plus 1. So how many lectures that we have just now? 4, isn't it? So let's write 4. So now we must change or substitute the plus 1 to the other side, which means it will automatically change to negative. So 4 minus 1 is equal to 3. So K is equal to 3. So now you just write the formula back in numbers form. So we have K. K is 3. And remember the formula N. N is 12, so you can denote it with the brackets, which means times, and plus with 1. So 3 times 12 plus 1. 3 times 12 is 36, plus with 1 equals to 37. So our answers for M is 37. So the numbers of lecturer, the minimum number of lecturer in the office, that to the 4 of them is born on the
Guys, hope you guys enjoyed the video. Thank you for watching. That's all for today.
My name is Tuan Muhammad Islam bin Basu. I'm the rules of PASCAL triangle are conventionally enumerated with round. Okay, you must sambung ni.
Next is the generalized pigeonhole principle. We can pass.
Gila. Dia tidak video dah.
Nakala mga pang sini. Tapi baik, diorang baik.
Okay, walaupun dia dekat-dekat. Syaz, ya kalau kita kena baik tadi orang.
So each of the
Pigeons.
N plus and 2 ways to either task. Example, did it...
Okay.
How we use three diagram to calculate the probabilities. Kan?
Hi, my name is Tuan Muhammad Islam bin Basu. I'm the rules of PASCAL triangle are conventionally enumerated with round. Okay, you must sambung ni.
Next is the generalized pigeonhole principle. We can pass.
Gila. Dia tidak video dah.
Nakala mga pang sini. Tapi baik, diorang baik.
Okay, walaupun dia dekat-dekat.
Ah.
Syaz,
Tak payah kalau kita kena bayi tadi orang.
So each of the
Pijol.
N plus and 2 ways to either task. Example, did it
Okay. How we use three diagram to calculate the probabilities. Okay. Okay.